Section 11.1 talks about differential equations. So we have two types of differential equations, ODE, that's ordinary differential equations, and PDE, partial differential equations. We're going to focus on ODE in this class only. So what's a differential equation? We're not going to call it ordinary, we're just going to call it differential equation because that's the only type we're going to focus on, the ordinary kind. A differential equation is an equation involving an unknown function of a single variable. So kind of like y equal f of x or y equal f of t, together with one or more of its derivatives, f prime of x or f prime of t, and so on and so forth, or y prime. A solution. A solution in general is the value of the variable that equates an equation. That's in general for an equation. So you give an equation that has a variable in it. A solution to that would be the value of the variable that equates the equation. For example, we're used to seeing x. What value of x do you substitute in the equation that will make the left side and the right side equal? Well, a solution to a differential equation is the same idea. So from now on, DE stands for differential equation. Instead of a variable, it's really a function. It's the value that you are given that equates the equation, that yields a true statement. So the first set of problems we're going to look at, you're given the problem, you're given the solution. Everything you see in this section, eventually you will be given this on the long run and you have to find the solution yourself. For now, they're saying, is the given function a solution of the differential equation? Well, let's see. Here's the solution. Here's the equation. What does the equation say? Well, if you take a derivative of y, well, what's the derivative of y? Let's see, dy dx. Isn't that negative e to the negative x? So if you take a derivative, which is negative e to the negative x, plus x itself, I apologize. I really meant to write y. I thought something was wrong because you need y and its derivative plus y. So what's y? Well, y is right there. And wouldn't that be a 0? So it checks out. Yes, it is. This would be a solution. How about part B? Part B says if you take x, multiply it by y, by the derivative of this, well, there's y. What's the derivative of that? dy dx is the product rule, negative 1 times e to the negative x plus x e to the negative x, because when you take the derivative of this, you pick up a negative, plus 3. So they're asking if I take x and multiply that by the derivative, here's the derivative. The derivative is negative e to the negative x plus x e to the negative x plus 3 minus y. And y is right there. Y is really negative x e to the negative x plus 3x. And would you get this as an answer? That is negative x e to the negative x plus x squared e to the negative x the 3 is no. What did it? Oh, plus 3. I'm sorry. Yeah, plus 3. Right. Distribute that in. That is plus x e to the minus x. Distribute that in. Minus 3x. And how does that work? If I look at, okay, I believe here, there we go. X times, there's the derivative. So this is really 3x plus 3. Okay, and what do I get? Well, I noticed that these two cancel out. And these two cancel out. And I'm left with x squared e to the negative x. There it is. Again, later on in the chapter, you're going to be given that equation and they're going to say find the solution. You're going to come up with this as a solution. For now, I'm given the problem and I'm given a proposed solution, checking if it is a solution or not. It's that simple. So how about this problem? This says, if you take two derivatives of y plus 4 times y, do I get a 0? Well, let's see. What's two derivatives? Y prime is negative 5 the sine of 3x times 3. So y prime is negative 15 the sine of 3x. And y double prime is negative 50, that's negative 45 the cosine of 3x. So if I take the second derivative of y, which is negative 45 the cosine of 3x, plus 4 times y, 4 times 5 the cosine of 3x, what do I get? I'll get negative 45 the cosine of 3x plus 20 the cosine of 3x. I will get negative 15 the cosine of 3x. So that doesn't equal 0. This is not a solution. This is, so it's asking, check if it is a solution or not. This is not a solution. How about part D? Well, same deal. What I need in part D, again, I messed up. You guys gotta forgive me. There it is. This says, if you take two derivatives, well, first derivative is 3e to the x plus product rule. 2 times e to the x plus 2x e to the x. So the first derivative is actually 5e to the x plus 2x e to the x. Actually, I need that. It's right there. So I'm going to color code the second derivative. Would be y double prime equals 5e to the x plus, again, the product rule. Derivative of the first times the second plus the first times derivative of the second. So y double prime is actually 7e to the x plus 2x e to the x. Now take this and put it right there. If I take 7e to the x plus 2x e to the x minus 2, and in place of y, that would be 5e to the x plus 2x e to the x plus y plus the original right there, 3e to the x plus 2x e to the x. And let's see if you get a 0. This would be 7e to the x. Actually, if I factor e to the x out of that, that will make my life a lot easier. If I factor e to the x, I will have a 7 plus 2x minus 10 minus 4x plus 3 plus 2x. I will get e to the x times negative 4x plus 4x, that cancels out, and 7 plus 3 is 10, minus 10, that's 0, and any quantity times 0 is 0. So my answer is yes, it is a solution. And a couple more to go. How about here? If I told you this is my function, if I take two derivatives of that, well, two derivatives, let's take the first derivative, that is 14 the sine of 2x, the cosine of 2x. And if I take a second derivative, that's negative 28 the sine of 2x. So if I take the second derivative, which is negative 28 the sine of 2x, plus 4 times y. Y is 7 the sine of 2x. Well, wouldn't that be negative 28 the sine of 2x plus 28 the sine of 2x? Wouldn't that be a 0? Doesn't that check? So my answer is yes, it is a solution. And how about if I looked at the last example in these types of example 1? I need two derivatives. Well, first derivative, is negative twice the sine of x minus 3 the cosine of x. And I need a second derivative. That's negative 2 the cosine of x plus 3 the sine of x. If I take the second derivative, which is this right here, negative twice the cosine of x plus 3 the sine of x plus y, twice the cosine of x minus 3 the sine of x. Let's see what happens. Those two cancel out and those two cancel out. I'll get a 0. My answer is yes, it is a solution. The last 3 problems are really straightforward. It says solve the differential equations. Well, let's see. How do you solve that? You cross multiply. And here in this section, it'll work that way. You integrate. And you will get y to equal the integral of 2x, where x is x squared plus c. There it is. You're done. Literally what we did in our integration. And how about this problem? If you cross multiply, you will get dy equals the tangent of x dx. If you integrate, y will be, we agreed, natural log of absolute value of secant of x. Or if you like, negative natural log of the cosine of x. Either or will do. Those are the same. And if I go for part C, if I cross multiply as well, I'll get dy equal the sine of x dx. So those are really straightforward, just to get you into the game. Y equal, what do you take a derivative to get sine? Negative cosine of x plus c. Very good, except they gave me when x equal pi, y equal 1. So 1 equal negative the cosine of pi plus c. 1 equal negative 1 times negative 1 is positive 1 plus c. So c happened to be 0 in this case. And here I would say y equal negative the cosine of x is the explicit solution of this equation. And that's pretty much it for this section. Verify and find the solution. Really straightforward.